It is my pleasure at this time to invite our final panelist moderator to present on cutting edge AI, a topic that is a fascination to all of us. It is being presented by Helena Wisniewski, who is a fellow of the National Academy of Inventors. She is the Marion Porter Chair and Professor of Entrepreneurship at the University of Alaska, Anchorage. Helena?
I see the timer's ticking, so. All right, well, good afternoon and welcome to Cutting Edge AI. The rise of AI has created an era of unprecedented technological advances that are transforming lives and reshaping multiple industries, from movies to medicine to even sports. If you watch the NFL, at the end they said they used AI. And they have digital athletes. So there are multiple questions that are coming up, and that's what the panel is going to address. And we're going to delve into how can universities adapt their innovation strategies to thrive in an AI-driven economy and make impactful collaborations with industry. How can we maintain the US lead in AI? And looking ahead, should we prepare for AI general intelligence to take over jobs, or is that hype? And digital twins is going to be one of the big directions in the future, especially endowed with AI. So everyone and everything will have a digital twin. So that's something to think about. And our esteemed panelists will share their insights and experience as a pathway to understanding the role of institutions in this new era. So I'm going to begin with some introductions to let you know a little bit about the background of our panel, and then we'll get into the questions. When we get into the questions, I'm going to ask you to please hold your questions for the end when all the panelists have spoken. So we'd appreciate that. So my name is Dr. Helena Wisniewski, and I hold the inaugural Marion Porter Endowed Chair at the University of Alaska, Anchorage. And I am a professor, and I'm also chair of the Management, Marketing, Logistics, and Business Analytics Department. I'm a technological entrepreneur who has launched over 12 startup companies and sold some. And I have seen AI evolve. I was an early champion of AI at DARPA as a program manager, where I initiated and led noteworthy advances in neural networks. And then I continued to implement them in industry when I was a director at Lockheed and a VP at Answer and Titan. And now at AI, I am preparing students for the new AI economy. And I'm co-founder of the Alaska Data Science and AI Lab, and created the first AI course in the College of Business, among other things. When I was Vice Provost for Research and Dean of the Graduate School, I created the Arctic Domain Awareness Center, and as the founding director, it became the first DHS Center of Excellence in Alaska. My current publication, and I'm excited about it, is Global Supply Chain Management and Emerging Technologies, and it's going to be published within the next few months. I'm a fellow of the National Academy of Inventors, and my PhD is in mathematics. I would like to now continue with the introductions. Dr. Nicky is a distinguished inventor, researcher, and professor with a profound impact on the global semiconductor industry, particularly through his innovation in integrated circuit and design and technology. He serves as a National Taiwan University Distinguished Research Chair and has founded several companies. His pioneering work was at IBM Research, which led to the adoption of his inventions in the world's first 8-inch wafer fab, significantly advancing RAM and CMOS technologies. And his contributions have notably enhanced Taiwan's semiconductor capabilities, reinforcing its status in the global market. He has over 60 patents and authored more than 60 technical papers. And his PhD is in Stanford, and he's a fellow of FNAI. Dr. Chen is a leader in AI computing and is a John Cocke Distinguished Professor of Electrical and Computer Engineering at Duke University. He's a principal investor and director of the NSF AI Institute for Edge Computing called Athena, and he's very proud of that because the award was made by the White House, and it's only one of 25 in the country. He is also co-director of the Duke Center for Computational Evolutionary Intelligence. He has authored over 600 publications and holds 96 patents. He has multiple accolades. He's a fellow of the FNAI and is the inaugural Artificial Intelligence Institute and a founding member of the Academic Alliance on AI. Dr. Fu is a renowned AI expert, a successful serial entrepreneur, and a distinguished professor at Northeastern University. He has authored over 600 scientific publications, and I asked him which one is he the most proud of. He said his seminal work is in image super resolution using large neural networks. And he's receiving investigator awards and founded a startup that was acquired by Shiseido, the cosmetics company, to enhance its global e-commerce through AI-based augmented reality. His PhD is in electrical and computer engineering from the University of Illinois at Urbana-Champaign. And then we have Dr. Dinesh Manocha.
Thank you.
He is the Paul Chrisman Iribe Professor in Computer Science, Electrical Engineering, and Computer Engineering, and a Distinguished University Professor at the University of Maryland, College Park. He was previously at Chapel Hill, and his research group that he's very proud of developed software packages in multi-agent simulation, robot planning, and physics-based modeling. But here's the key thing, is they're licensed by over 60 commercial vendors, and he's published over 760 publications and supervised 50 PhDs. But his work is also licensed by companies, and he's transferred technology to multiple government labs. So that gives you a little bit of an idea of the talent that we have here for today. And so let's move on to the questions, because I know you really want to hear what the panel has to say. First question will go to Dr. Liu. Given the rapid shift of AI development and other emerging technologies into the private sector, how can universities adapt their innovation strategies to remain relevant and impactful in the new strategic economy? And with that, what specific changes need to be made in their approach to research and collaboration with industry?
Okay, I answer it or?
Yes.
Okay, thank you. So I traveled from Taiwan to here, and now Taiwan produces 50% of the wafer, which half of them prepare for future AI world. And I'm glad that I can tell you later, if you are interested, how the Taiwan today in semiconductor clusters. But she gave me the question, which is very broad and deep. So I prepared my manuscript. So first, an AI-driven economy is certainly on the horizon. There are a lot of debates, but I tell you it's on the horizon. The impact of this transformative technology surpasses that of the cell phone, PC, and mainframes we have ever experienced over the past 50 years. So this AI time is surprisingly come very fast rush and will be big. So today I answer her question. I like to use 5 I's to describe this new era of intelligence, brimming with innovation and opportunity for all of us. First, AI. Second, IC chips. Third, semiconductor. Fourth, HI, heterogeneous integration, which is a new technology to put many known good dies integrated in a small module for microsystem. So recently, NVIDIA, Dr. Jensen Huang talked about his microchips. Inside is heterogeneous integration, including DRAMs. And the future, gallium nitride, photonics, and many new memory will be integrated. The 5th one, I, is IoT plus advancement in communications. So all these 5 I's, knowledge domains and skills, are so broad and deep, and we must learn and let the university professors to teach our younger generation how to remain as a master in the robot age. While AI and robots will handle very broad and deep knowledge bases that human beings can memorize or organize. So mankind retains advantage in creativity, empath, and adaptability, adaptation to the changes. Not too many compared to robot AI. However, our educational system must evolve swiftly to enable humans to maintain their roles as smart masters. Given the broad scope of these 5 I's, my proposed strategy, we can take a vertical integration along the knowledge of these 5 I's to establish essential courses, allowing students to pursue and fabricate their own solution for preparing their lifelong learning to swift changes, adapting to future needs that are unknown today yet. So horizontally, I think students must grasp the fundamental STEM capabilities alongside aspects of humanities, law, economics, and biomedical sciences. So for graduate level education and training, I propose adopting an MSEL approach, mentorship, solution-driven creativity, entrepreneurship, and leadership. This method promotes more adaptive teaching style compared to traditional top-side-down classroom knowledge transfer approaches. We must foster impactful innovation and invention to the younger generations. Allow me to elaborate it. First, mentorship, providing crucial guidance to steer young talents towards successful career and fulfilling lives. So professors, mentorship is our responsibility. We may not give mentorship to robots, but we have to give our younger generations. Secondly, solution-driven creativity. You don't do creative just for creation. You do creativity, creation, and creations for real solutions. Third, entrepreneurship. I think embracing challenges, making tough decisions, and overcoming obstacles. Fourth, leadership. Benefiting oneself while making enduring contribution to society and humanity committed throughout one's life. So finally, As for major change expected from an industry perspective to universities, like the question to me, industry, when hiring students, we seek those students equipped with MSEL, strong STEM backgrounds, and the ability to innovate independently with tenacity and determination. They did acquire skills in school, enable them to tackle challenge more effectively in our industry. So please, train your student like what I proposed. I founded 7 companies, 3 of them public in Taiwan. If you don't train your students in the new mode, I think robot will make me trouble. So one vividly recall my own memory when I joined IBM Research, Yorktown Heights, after graduating from Stanford. So upon seeking guidance from my supervisors, Bob Denard, who was the inventor of DRAM, and Lou Terman, who was IEEE president, on how I contribute. Please tell me on how. What's my job? Their response was very enlightening. I want to share with you. They said, Nicky, I thought when we hire you, you were recommended by your professor, Jim Meadows. IBM Research had hired you not just to follow our directions, but please discover and forge new paths due to your own existence and wisdom. So for 3 years, my manager never talked with me. And within that 3 years, I made my very significant inventions, contributions, because I'm very, very disturbed. However, because of that tough time, I think IBM adopted my invention to put the world first 8-inch wafers. Then I was invited by Morris Chen to go back to Taiwan. My deal is let me start up a company called Etron. Within 3 years, Taiwan 8-inch wafer fab was built. And now we involved, and I was involving very deeply as I'm chairman of Taiwan SIA, and I know most important is your education in university and my education in the industry. All together, we will create something, a new strategy for AI robot world. So I think robots are very powerful. I have experienced. And I think we need to define the skill which can be adaptive. And the university, your students, your output as your product will be, in my eyes, of potential industry people. So industry count on university, new strategy, new teaching methods. We cannot avoid mentorship. That's so valuable. And thank you for listening to my specific proposals. Thank you.
Well, thank you very much. And those are some really good takeaways from your presentation. So everybody has to go out, go forth, and implement. So our next question is, how is AI reshaping your university's innovation strategies? Please provide a few examples. How can these innovation strategies contribute to keeping the U.S. lead in innovation and AI? Dr. Chen.
Okay, when I received this question, they particularly asked me to give some examples. And I think, Nicky gave very good, a proposal. So at Duke, we constantly talk about how the AI will reshape our research as well as education. Okay, so I'm wearing multiple hats. On one hat is about AI advisor to our dean, talk about this. So in one meeting of the BOV, Board of Visitors, so some people ask our provost about the position of Duke for AI research and also education. So if Duke is able to invest, especially heavily invest on AI research on the first, the answer from our proposal is actually no. So it's not just because we don't value the basic importance of the AI. It's more about how we vision AI as just a pure research or computer tool we're going to use in any other applications. So now the AI actually is everywhere. So AI is more like a calculator, the high schooler are going to use. It's not just like, some pure research who actually try to pursue the different things. So people don't need to understand how the digital circuit work when they are using calculators. Similarly, people don't need to really learn how this deep neural network and model can converge, can be trained or something first, which we can use this model for something good. From that perspective, we created some courses called the computer engineering, machine learning, and the neural network. We basically teach our students how to use those tools, especially the deep neural network, to solve the engineering problem rather than we teach them how to mathematically derive the equations on the first. I think that's been very important. So AI is basically an education tools everywhere now. Okay, so that's another example I want to give to you. I can give a very specific example. My research is more about the AI computing system, but not the AI models as the Dinesh and also the Raymond are doing. So we are particularly interested in how we are able to design the computing system running more efficiently and also reliably. There's one tool when you're designing the hardware, I think Nicky also knows this, it's a Verilog language. It's basically using the language to describe the behavior of the digital circuit and also to run those things to simulate the circuit. So in the course, we teach the student how to program these languages, and later on people find out that they can use a Copilot to help them to program this language, like a ChatGPT or some other stuff. But at the very beginning, back to 2 years ago, when people start using the GPT-2 to help them to program this language, the language was programmed in a very bad shape. Nobody going to understand what the AI tool is going to program. Nobody understand what's going on there. So we start doing our research on how to improve this automatic tool using AI models and so on first. However, after 6 months, when GPT-3 came out, they can write a much better, program of the code than they have done in 6 months ago. So we keep monitoring this progress. After another 6 months, so that's 3.5, basically write an even much better program. And now if you see the ChatGPT -4, 4.5, they can perfectly write the code with the similar quality as a programmer going to write, just within roughly 24 months, okay? So my point is this. If we really look at the whole computation between the silicon brain and the human brain, we're not going to win, okay? Because the silicon industry, thanks for the Nicky and some other pioneers, they actually build up the good ecosystem. They can evolve so quickly than basically the biological brain can evolve. I think that is something we learned. So we stop that research, okay? Because let's the AI tool to take over the programming and so on first. That's also Jason Huang. He also mentioned this. So what should we do? Okay. If you look at how we can use AIs, the AI can quickly learn what we couldn't learn using human brain in a very short time, and it can memorize many things. They can explore a lot of combinations of those knowledges, the pieces of the information so on to generate something very new. Okay, this is actually a creation of those ideas. A lot of people challenge saying, the AI has no ideas and no creativities or something first, which is not true because of many creation, just the combination of all these informations. We need to acknowledge this. Of course, there's still some corner where we'll not be able to do this, but that's fine. So by doing this, some people actually try to develop the tool, actually led by, also supported by a billionaire. I cannot name the name, but you can Google his name because he donated $1 billion to Caltech doing some stuff. Okay, he actually led the group, to develop the tool which can function as agent to talking to the researchers in the science and participate in the research. For example, we can talk about how we can create this recipe for this yeast experiment. So we can talk about how we can interpret, the results on the first. And this AI tool can participate in this discussion because the tool has written many papers and it can participate in this discussion. So this actually will dramatically change the way we're going to do research because we don't need to read those papers, it can summarize for us. And we can leverage this capability of the AI tools to really advance this research. Back to the AI Institute I led. In the same year, there is another AI Institute that was founded by National Science Foundation doing AI for education. That was led by an associate professor from, I believe he's from Utah or somewhere. So he's very young, okay? So it's very unique, for an associate professor like this National AI Institute. So I actually attended one psychology conference, try to see what he's gonna talk, because he was giving a talk there. When he opened up his PowerPoint, there's only one slogan actually at the display, basically saying, you should not work like AI work for you. You should work with AI. Like AI work with you. I think that is very important, the words actually he tried to deliver when he wrote a proposal for the AI Institute. That's why he received it. Of course, now he's a distinguished professor on the first. I think that's the final say I want to deliver here. So don't let AI work for you, let AI work with you. That's how we translate the whole message. I'm done, thank you.
Well, thank you for that inspirational comment, and I think that's very true. You look at robotic-assisted surgeries, right? They're not doing the whole surgery, they're assisting, and that's a key word. So that's a very important point. So, what about the future of university research in AI? As AI continues to evolve, what will the future role of universities look like in terms of developing cutting-edge AI? How can universities leverage their strengths in fundamental research to contribute to significant breakthroughs in AI and foster an environment that supports practical, outcome-oriented innovation? So that's a tall order, deep question. Dr. Fu, would you like to take that?
Thank you, Helena, for the question. And I'm so lucky to be in the AI field for over 20 years, and since I was studying as a student, and I think I'm experiencing the evolution of the AI research from university to industry and also to entrepreneurship. So it's my privilege to share my experience. I think when I was a student around 15, 20 years ago, so research field, especially in the academia, is a highly centric. So basically, when you go to an academic conference, in my field, for example, CVPR, Computer Vision and Pattern Recognition Conference, which is so far considered as the topmost AI conference, it's actually happening right now in Seattle. So back to that time, when you go to the conference, it's a very small conference. You don't see a lot of people, but you know everyone. It's a small community. And most people are from university, from research labs, and so you know everyone. And every year you see the same faces. But if you see right now, I mean, it's totally different. I know today when people attend the CVPR conference, even I was not there, I was following what's going on. And my friends told me, okay, there are several rooms because it's overcrowded. And they actually closed the session, like this panel, for example. They closed the session, so everybody go out, and it goes virtual. So you can tell the difference. And also the people in the room are totally mixed. People are from industry, people from government, people from university, from research. And so this evolution tells us, actually, university and the industry, they are in an ecosystem. In the 20 years ago, this ecosystem has a clear gap between university and industry. So university only lead fundamental research. They are funded by government. And then their main goal is to educate the students. So students, they learn from professors, and they get good scores, and they get a good resume, then find a job. And industry, actually, they try to hire talent at that time. But they are more like market-driven and service-oriented. And until today, the big change is now we don't have this gap anymore. So university and industry, they are collaborating. So if we consider the cutting-edge AI research of the future, there are three main factors I would consider is going to drive the momentum. So the first factor is about the talent. The second is about resource. And the third is innovation. So university in this ecosystem play an important role, and more important in here and the future, because university is an indispensable hub nurturing talents and future researchers. And also university creating a lot of patents, technology innovations from long-term, long-lasting fundamental research. And industry, actually, they have enough resource. Nowadays, when my students want to do research, they always tell me, hey, professor, can I go to industry as an intern or co-op? Because they have a lot of GPUs in their company. I want to take advantage from that. So, for me, this is a big change compared with 20 years ago when I was a student. I don't have a need of GPU, and I just need a top researcher to supervise me. So I think this ecosystem is healthy. It's quite healthy. That's why our AI field is moving so fast. And if you look at the industry turnaround of each cycle of production, it's less than months in the software system, in the software industry. So I think for future research and for university leaders, they are going to be more open-minded, and they want to provide more effort to support collaboration between university and the industry. They want to provide more opportunities for their students to experience any practical and practitioner-driven research and development and applications. So I'm from Northeastern. I think Northeastern did a great job in this field. And we have a co-op program, which is like students take 5 years at the school. And there's 1 year specifically for collaboration in industry. So they do 1 year full-time research and application and closely with industry practitioners. So I think the future is bright, and the AI, cutting-edge AI research is going to be more significant in the future, and we're going to convert to an ecosystem that win-win situation is going to happen. That's my comment.
Hey, well, that was inspiring. Thank you for those insights, and look forward to that future. So speaking of the future, is it hyper-reality? Okay, you hear a lot of people saying in 5 years, we'll have general intelligence AI systems that will then take over most of the jobs. Or is that just hype? Is it a prediction or hype? And Dr. Dinesh Manocha will inspire us about that.
Yeah, thank you. It's a really interesting time. If you watch the news today, the 3 top companies in US are, like in stock market valuation, Microsoft, Apple, NVIDIA. They all have valuation of $3 trillion plus, which is bigger than the GDP of many of the countries in the world, and it's all driven by AI. So the generative AI era, you heard all the great things. But let's go back to reality. AI is not a new field. What we call of AI, artificial intelligence, was conceived by a bunch of academics at a conference that happened at Dartmouth in 1955. I wasn't born. I don't know how many of you were born that time, right? So I tell you my story. I was undergraduate in India in the 80s, and I went to Berkeley grad school in 88 to do PhD in robotics. I was just excited by science fiction, robot, math. When I entered the grad school, AI was still a hot topic, nothing like today, not an industry. When I finished my PhD in 92, whole field of robotics and AI plummeted. There was a big winter of AI. How many of you remember that? So, and then what we're seeing today, this is the so-called AI, this happened around 2011, 2012, is a field of AI what is called machine learning, and generative AI right now, which is driven by a lot of data and compute. So we have seen amazing advancements every day for the last 12, 13 years. It's a kind of AI called machine learning and this thing. So clearly, all the three speakers I told you about the potential, how it's changing everything, education, enterprise, robots, yeah. But let's be careful. The latest generative AI, which is a lot of media attention nowadays, is it really has human-level intelligence? ChatGPT can do amazing things sometimes, but ChatGPT gives you dumb answers also. So I'll give you one good example. Like Tim Cook, Apple CEO, made a statement 10 years ago. One impact of AI would be transportation. Transportation is a $4 trillion industry. They sell about 100 million cars. We all drive, right? And we all talk about traffic. Which part will it come from? So all the companies, the computing company, the car companies are investing in self-driving technology, autonomous driving, Waymo and all that stuff. In 2009, 15 years ago, I've heard projection they have burned close to $70 billion from venture money, company money. Elon Musk promised you that you're going to have fully autonomous cars by 2017, 2018. By 2020, there'll be no ownership. We'll be all doing it. Here is 2024. After you spend $70 billion, where is my autonomous car? I drive a Tesla, but I don't use the full self-driving option. I don't trust it. Okay? So the challenge is, while AI is great, is a great assistant, as Professor Chen mentioned, from all fields, education, medicine, government, policy, you name every sector of the economy is touched to it. But sometimes the hype exceeds the reality, And this is what Taiwan told us again. So I think AI is a great tool. It is affecting our life every day in every way, but don't overhype it. Because we have been burned once in the 1990s, the winter came, and every time we overhype, you know what happens. So it's a great thing. As a researcher, I love it. In fact, one thing I should also mention to you, and I'm a computer science professor, ECE, the amount of student interest we're getting, everybody, the number of CS majors, in Maryland, we've got 4,000 majors, we don't know how to handle it. We get 3,000 applications for our PhD program. We can barely take 50 or 100 a year. 80% of them want to AI. The amount of, the brightest mind in the field, the young kids, AI robotics, it's really affecting everybody. We're drawing amazing talent. It's good to be an AI researcher. Funding is high, excitement is high, but at the same time, all of research have a responsibility to society. Please don't overhype it. And don't promise something which is thing. One thing I do a lot is robotics, right? And right now, people are saying robotic idea has been around for 50, 60 years. You hear in the media, robotics is going to have its ChatGPT moment, just like what ChatGPT did, right? Your writing and all the amazing thing. Even Jensen has been saying, okay, in 5, 10 years, we're going to have 10 billion humanoid robots. We got close to 8 billion humans on this planet. Let's talk about 10 billion humanoid robots. Do all your chores, fold your laundry, wash your dishes, name it. I've been working with robotics for 40 years. I'm not sure it's going to happen. I get asked questions by the media all the time. when is autonomous car going to happen? And I tell them, I'm 58. If it happens in my lifetime, I'll die a happy man. So there's a lot of potential, a lot of possibilities, but please don't overhype it. There are challenges, a lot of challenges to solve, and some of these problems could take very long time for all the billion researchers to solve.
Well, I think that's really good advice, and we'll see in future years what happens. But your point about robots, in the 1960s, the first commercial robot was actually used in New Jersey in GM Lab. And everybody was afraid the robots were going to take over and take all the jobs. That was in 1960. They still haven't. So I think that kind of supports your point. I think things will really grow, but we'll see what happens in the future. So would anybody on the panel like to take a moment and elaborate on anybody's views? Or is there another point you'd like to make that wasn't made? Okay.
Okay, whether AI is hype or real, it's a big gamble. But I want to tell you, the semiconductor industry, about 10, 15 years ago, we thought Moore's law dead. But fortunately, we right now arrive at 2 nanometer stage. Taiwan will produce 2 nanometer manufacturing technology for many AI machines, 2026. Before that, heterogeneous integration will combine 3 nanometer chip, gallium nitride, many unexpected, like photonics. Probably a lot of people are working on photonics. I think it's coming. Moore's law didn't die. However, I took the most advanced semiconductor performance and density, cost, and power is totally deviated from so-called Moore's law. That means 2 nanometer, we're supposed to have 1,000 million devices, transistor, in 1 millimeter square chip. But today, even the best factory only produce 200, 5 times smaller. There are tremendous opportunity between 10 nanometer to 2 nanometer. A lot of invention, innovation, many things there. Now, semiconductor guy is remain so optimistic receiving our AI customers, because I never had that experience. ChatGPT 4.0, just right on my desk. I asked him, I used him, okay, or her. The question, she answered better than I did. I don't understand because I'm not software guy. I don't understand the algorithm. If you are experts in algorithm, please let me know why. But hardware guy, I know, will provide you this, which unexpected in the next 10 years. So the economy allows that. So NVIDIA total market value is bigger than the sum of Intel, TSMC, maybe it's bigger company, data company. I don't elaborate it. It's hype, maybe in the stock market. But I remember 30 years ago, I left IBM and go back to have big gamble with Morris Chen to build silicon fab in Taiwan. That's almost mission impossible. But that gamble was thrown in. Today, we produce so many devices. And fortunately, because we have that capability, many force to support Taiwan without getting into the war. If Taiwan get into the war, 50% of worldwide economics will be gone. I sense it, I recognize it. So gamble. But don't teach your student to gamble, but they are gambling now. But with my responsibility in the semiconductor world, I tell you, a complete microsystem now be integrated in M4 chip of Apple or B200 in NVIDIA. So this gamble is big. I agree with him, but you want to do it or not? Thank you.
Okay, just in the interest of time, does anybody else have a comment?
I think we should do it.
We should do it.
Definitely spend all the money and invest, but be realistic. Don't overhype. Don't promise which you probably can't deliver in 3-4 years.
But surprisingly, the volume of 2 nanometer TSMC production volume has been all booked. You don't have the chance to get the wafer in the next 2 years. Human beings may get crazy. The AI robots, like your expertise in the robot, may get crazy. But I want to tell you, my personal experience is not crazy. It's really come.
Well, I think at this point,
Very
so that-
debatable.
I think we should just have maybe one more comment so we can get questions from the audience. So does anybody else like to contribute?
We would rather to give more time to our audience.
Okay.
Yeah.
So now it's your turn. Who has questions? Please come up to the mic.
I think I have a question for Yiran. She's talking about the alpha 3. I think the alpha 4 alpha 4 is come up with the protein. The alpha 4 3 is the RNA. And recently, the alpha 4 company and many company partners asked me, guy working on RNA, asked me to be a consultant and do something with them. But I have a question about it.
Sure.
It was 7 years ago. 7 years ago, I want to do computation for the last databases, machine learning and last database entry. But I found it out at the time, the major issue is we do not have enough database. RNA is difficult to make that because one structure takes about 5 years to solve that, also cannot solve it by itself. So now become the problem here is, protein have a lot of database, it's no problem, but I have a huge stock of the database. How can we solve this problem to use Alpha 4.3? That's my question.
It is a very good question, and also it's one of the biggest challenge for us to continue developing the next generation AI. So we already run off all the data we have, believe it or not. Let me tell you a story. So Altman, actually, he gave a talk a couple of weeks ago in Stanford, and there was a long queue of people trying to get into the room, okay, so you understand this. And there was one guy asking about if you ever use YouTube data to train the ChatGPT or GPT. Guess what? His answer is, good question, let's pass it. So it is an issue. We already run up all the real data we have in the whole world. And the only way people are talking about, so Raymond and also Dinesh know, we actually try to synthesize the data to basically artificially generate the data, train the model. And you see, a lot of really weird things like you could generate, the photos, people have the 6 fingers or something first. Those are, something we actually learned from this. So we don't know, the perfect solution yet, but I think all the researchers are working on that. And also in some other factors that we don't have sufficient data. I had a conversation with David, yesterday and also morning about people don't have sufficient data when people are doing AI for science, particularly physics. Then you need to measure a lot of, the samples, the devices, but we don't have those measurements, result, to really train our models. So on one side, we have a lot of data. We already use up all the data. On another side, we still don't have sufficient data to train the model. We need to focus on those sectors.
Yeah, I think 8 years ago, I already see the problem and organized a team to work in the database about RNA structure. But I'm late at the time. I'm not an AI person, and now they come out. But I have a solution to that. But we can talk about it after the meeting.
Of course.
Thank you.
Yeah, sure.
So I think one thing I should add, the AI today is as good as the data itself. So data is the gold mine, That's what really drives the current AI technology.
We have Time for a short question.
Short questions. Thank you for enlightening. There's a hardware going into the nano, maybe 1 nanometer chips that you can bring it up. So really GPU is driving the speed, right? So previously we do dynamic modeling of drug lipids, drug multi-component simulations. So we burn through the university mainframe. So now with GPU, we might be able to do it a lot faster, right? So the question really is that how good of your data input, for example, we can envision things like literatures, right? So you have a lot of data in medical field. If you can then put it together, right? You spend months and years to accomplish these studies and be able to precisely validate it and says, this is really the link of disease versus this is the outcome that we should look for, right? So that's a complex system that I would be very excited about. You know, the scary thing that you talk about is that, you know, a lot of CS students wanted to have a Microsoft jobs, Amazon job. If they can write the program for them, that will be a scary thing. But the other part that really good for us is that we can predict and simulate with the power multi-chips to get there, right? So that's really where the excitement is. Whether we're going to perfect it in a year or two or not, is the questions.
Well, I don't know how to answer your question, but I think putting all things together for a superpower microsystem, we had the previous example because we first used mainframe, like I work for IBM, and later people said microchip with inside notebook connected together for array will replace that one. Now, the AI chip with knowledge, wisdom, everything is as small as my fingertips. If you combine millions of this kind of self-learning AI chip, I think it may replace today's supercomputer. I hope quantum computer is coming. But anyway, my last sentence is that the only force to inhibit the progress, like the hype we're talking about, we human beings don't know how to generate so much energy to support this AI world. Currently, the curve shows that impossible unless we gave all the energy to playing AI. So that's real. That's another real. However, Microsoft and OpenAI said they will raise $17 trillion. Today, the semiconductor industry only $0.6 trillion. TSMC is less than $0.1 trillion. So somebody said we want to have $17 trillion. I don't know. Human beings crazy. Okay? We want every power. You guys can innovate and generate it. Otherwise, okay, we don't have the air conditioning here because all the energy be absorbed to the AI data centers. Sorry, run out of time. Your conclusion.
What I'd like to say is thank you very much, panel, and let's give our panel members a round of applause. And then give yourselves a round of applause for attending and your questions.
Yes, indeed. Thank you, Helena, and thank you to a wonderful panel. AI, always an invigorating and exciting and sometimes frightening topic.